So I don't think every sort of advancement within the field of artificial intelligence is going to be this massive splash, but I do think a lot of things are really cool when there's iterative improvements, like with the Gaze LLE, which is a gaze estimation computer vision model to see where the likelihood with high probability someone is looking and why. Why would this be important? For a variety of reasons. So here's the study released by all these authors from Georgia Tech and University of Illinois, and there's one use case, a big use case as far as being an ex-athlete, of understanding where, as a training or a film study, where someone's looking. Especially in baseball, you got to make sure that your eye contact watches the ball meet the bat. Same with golf, watching the ball hit the club and keeping your eye down. But let's imagine like a middle linebacker surveying defenses. If you want to look at game film, why were you looking over here versus over here? And understanding how we can use that as an additional tool. But there's also instances in probably a more mainstream and better use for a lot of individuals that are businesses putting this into different other businesses for their end customer, would be like safety, maybe security, seeing and evaluating exactly where your eyes and where you're surveying. Or if you're in a construction site, hey, why didn't you see this crash? Or why weren't you looking over here and supervising? Or you could have prevented injury if you were looking here instead of here. And yes, there have been previous models that have shown what gaze estimation looks like. One being NVIDIA and their TAO build kit, their GazeNet model card. But it's computationally expensive or requires a lot of training and fine tuning. So that's what I'm talking about when I'm talking about the iterative improvements, making things easier. And that's what Gaze LLE and these individuals did. Not saying that this is the best, but so far it does appear to be something that simplifies the entirety of the process of being able to use a Gaze LLE library like this straight onto your videos and get to deployment of your solutions much quicker, which is what we all want. We don't want a lot of ML engineers and data scientists on the front end doing this constant development process in order to get the end result, and because it's just so costly. That's the huge thing with understanding what ROI is in artificial intelligence. Let's make it cheaper up front so we get to deployment and realize the benefits later. In this case, you can imagine that if you're going to improve safety standards by seeing where individuals are looking, then you're going to reduce your costs for insurance and liability and all that. So the individuals here built it on what's called the Dino V2 backbone. And this is where I love, again, open source of artificial intelligence. This is Meta. Meta develops this, they put it out there. It's used for object recognition, image segmentation, a number of other things to identify what the different pieces of an image are. Why is that important for this? Because there's multiple elements that need to be realized for this to succeed. So you can see here, if we blow this up, okay, so here's where with certain likelihood that the individual could be looking at. This is the ground truth, and that's not all, because we have eyeballs, right? So there's got to be a bunch of elements of image recognition, understanding where the head is, and then the eyeballs are looking. So then you have with the no head prompt, this individual could be looking at here, but here, if you can see that it's unlikely they're looking way over there when their head's prompt towards this way. Then the last element, with the benefit of using this Dino backbone, they can see with much better likelihood that this individual is looking here. But, oh yeah, you can see over here. So this individual, there's no way they're looking way to their right. They're looking straight down. So you put that all together, and then you're getting much better performance than existing gaze estimation models. And again, this is all about reducing the computational complexity and the fine tuning and all the upfront work that needs to be done in order to get the deployment faster. Not saying again that this is the best gaze estimation model out there, but this is a really cool next generation of where things are looking at. And you can see here with this video that it looks pretty cool. I don't think this could be used for things, especially with my lawyer background, for looking at surveillance and seeing whether or not a person was looking at something or doing something, just because it's all based on probabilities. And when you're even at a 90% probability, there's 10% chance that something didn't happen. But as a tool for improvement, for training, whether it is in business or in sports, this is a pretty cool advancement with computer vision.